I'm Guang Gong, a professor in the Department of Electrical and Computer Engineering. I'm also a member of Cybersecurity and Privacy Institute. First is signal design and physical layer security. And the second will be the net-weight cryptography, net-weight post-quantum graphy with application in IoT. And the third area will be the blockchain privacy-preserving machine learning, like those federated learning systems for mobile devices. If we consider very constrained IoT devices, like those radio frequency identification called RFID, so they also divided into the two classes. One is EPC tag, those is very cheap. Since the cost is small, their computation power also small. Then you could also have Zigbee devices, like those sensors you already see, like those automated cars, they may have more than 10,000 sensors there. Then you could have a third class is more powerful, like your cell phones. Then you also have those very wearable devices. So those also belong to RFID type. If we consider fridge, or smart meters, those are static devices because they do not move. Mobile devices, for example, the smart cards and the sensors in the healthcare, so those moving, then they need to connect to the cell phone as their first step, and the cell phone connected to the backend servers. So those security mechanisms are different. Also, the authentication, access control, those are all different. Their networking communication protocol also different. So this is why make implementation of the security mechanism much more challenging. So usually you will have multiple crypto primitives implemented on your tiny devices. But our approach is you just implement one, then you can provide multiple functionalities. So that's what we are targeting for. One type of attack to those challenge authentication protocol is we call the relay attack. For example, you have those keyless entry car. Basically, when you're close to your car, then your car sends the challenge number. Then your key will generate the response. However, attacker can manipulate this. For example, the victim is far away from their car, but he stands in the middle and sends the challenge to the real owner. And the real owner will reply with the actual cryptographic authentication token. Then authentication will be successful, then he can open your door. So that's why we look at the physical layer. Because when you communicate, you have third party in the middle, then your channel will be different. So currently we can detect this difference. There is a man in the middle or there is no man in the middle. Then if we can detect this, then we can using this unique channel information to add as part of the authentication token. So that's currently we are working. I think if you want to take this as your career, then that's the fantastic. But the first thing is you have to know this type of the work. Digital technology is always evolving, which means attackers' knowledge and skills also advanced. So you always need to have the critical thinking, creativities to look at those new technologies, to think about how you can defend the current systems, even the future systems. So you have to have a passion for this career. However, this is also make this job very interesting.